no earlier than May 21st, 2026. During a 90-minute launch window opening at 5:30 p.m. Central Time, Starship will rise to the skies once again. But this time, everyone will be watching closely, because Flight 12 is not just another test flight. There's a reason not only SpaceX, but the entire U.S. space industry is waiting for this mission. And today, I'll tell you why. For the past few years, most SpaceX Starship test flights have been remembered for the huge launches, fiery explosions, and major engineering challenges along the way. But Flight 12 could mark a very different moment for the program. Instead of just testing experimental prototypes, this may be the point where Starship starts evolving into a truly reusable heavy-lift rocket built for actual operational missions. Ship 39 is the very first version 3 Starship, and it's unlike anything SpaceX has built before. V3 is basically a clean sheet redesign of the vehicle. After everything learned from versions 1 and 2, SpaceX stepped back and looked closely at what caused the biggest issues, whether it was performance, reliability, or manufacturing complexity. Then, they redesigned the rocket to solve those problems directly. The new vehicle is slightly taller than previous versions at around 408 feet, or about 124.4 meters tall, and it comes with upgraded structures, improved systems, and an entirely new engine. That engine is the Raptor 3, a high-performance engine designed not just for power, but also for reliability and rapid reuse. SpaceX learned a huge amount from building roughly 600 Raptor V2 engines, and you can clearly see how much simpler the new design has become. Compared to earlier versions, Raptor 3 has far fewer visible pipes, components, and extra hardware. A lot of systems were integrated directly into the engine itself, which required major coordination between different engineering teams. That simplification has some big advantages. Fewer parts mean the engines are cheaper and faster to build, easier to maintain, lighter overall, and potentially much more reliable. And all of that helps SpaceX move closer to building a better rocket system overall. Perhaps the most eye-catching number is the projected payload increase. Earlier versions of Starship were expected to deliver around 35 metric tons to low Earth orbit, but version 3 is aiming for more than 100 metric tons, or over 220,000 pounds, while still remaining fully reusable. To put that into perspective, the legendary Saturn V could deliver about 118 metric tons, or roughly 260,000 pounds, to low Earth orbit. Starship V3 is being designed to operate in that same category of capability, but with the added advantage of full reusability. And that's really what makes the entire program so ambitious. Now, even though Flight 12 will not actually carry 100 metric tons of payload, it will still attempt something no previous Starship test flight has done before. One of the biggest objectives of Flight 12 is to demonstrate Starship's future role as a massive deployment platform for the next generation of the Starlink constellation. Ship 39 is expected to carry 20 Starlink mass simulators, designed to match the size and weight characteristics of future Starlink V3 satellites, along with 2 specially modified Starlink satellites. That's a major jump compared to earlier test flights, which only carried around 8 to 10 simulators. The payload deployment sequence is scheduled to begin roughly 17 minutes after liftoff and continue for around 10 minutes. This will allow SpaceX to test the payload door system, release mechanisms, and satellite handling procedures under much more realistic operational conditions. Altogether, the simulators represent tens of metric tons of payload mass, giving engineers valuable data on how Starship performs while carrying loads closer to what future commercial missions could look like. But perhaps the most interesting part of the mission involves the final 2 modified Starlink satellites. These satellites are equipped with cameras designed to inspect Starship's heat shield while the vehicle is still in flight. During the mission, they will capture external views of the heat shield and send the imagery back to SpaceX engineers for analysis. To help with the inspection process, SpaceX has intentionally painted several heat shield tiles white to simulate damaged or missing thermal protection tiles and make them easier to track visually. In another deliberate experiment, one tile has been removed entirely, so engineers can study how re-entry forces affect the surrounding tiles during atmospheric descent. Until now, the heat shield has remained one of the biggest, if not the single biggest, ongoing challenges for the entire Starship program. The vehicle relies on roughly 40,000 hexagonal heat shield tiles that must survive temperatures exceeding 1,500 degrees Celsius, or around 2,700 degrees Fahrenheit, during re-entry, while also handling the intense vibrations and stresses of launch. SpaceX is still working through several major issues, including gap heating between tiles, tile brittleness, attachment strength, and the way superheated plasma flows around the vehicle during re-entry. Even losing a small number of tiles could expose the stainless steel structure underneath to extremely high temperatures. Elon Musk has repeatedly described the heat shield as the biggest remaining obstacle to achieving full and rapid reusability. According to him, nobody has ever successfully developed a fully reusable orbital heat shield at this scale before. The system not only has to survive re-entry without overheating the vehicle, but also endure launch and ascent without tiles breaking loose in the first place. At one point, SpaceX even experimented with metallic heat shield tiles as a possible alternative to ceramic ones. But during testing, the metallic tiles experienced serious oxidation problems under extreme heat, so the company eventually shifted its focus back toward improving the ceramic tile system instead. Version 3 Starship now includes several refinements aimed at solving those issues. SpaceX has improved tile bonding methods, tightened the gaps and sealing between tiles, and worked on creating a more uniform overall heat shield structure. The hope is that these upgrades will make the system both stronger and more reliable during repeated flights. Together, these tests in Flight 12 could provide extremely valuable real-world data on heat shield durability, damage detection, and overall thermal protection performance, all of which are critical if Starship is ever going to support rapid reuse and routine return-to-launch site operations. The mission also highlights how important Starship is to the future of the Starlink program itself. Since SpaceX has repeatedly said that the largest next-generation Starlink satellites simply cannot be launched efficiently by the much smaller Falcon 9. One of the most important and probably least understood parts of the entire Starship program is orbital refueling. In simple terms, Starship is being designed so it can rendezvous and dock with other starships in orbit, then transfer propellant between vehicles. That capability is really the key technology that unlocks the full potential of the system. Once you can reliably refuel spacecraft in orbit, missions to the Moon, Mars, and eventually much deeper into the solar system, suddenly become far more practical. Unlike the Apollo missions, which launched toward the Moon in a single flight using the Saturn V, SpaceX's lunar architecture depends on multiple launches working together. Under the current plan, a Starship Human Landing System, or HLS, would first reach Earth orbit and then be refueled by several tanker starships before heading toward the Moon. It's an incredibly ambitious approach and also operationally complex, but the advantage is massive increases in payload capability and mission flexibility. Instead of building one giant expendable rocket for every mission, SpaceX wants to create a reusable transportation system that can be refueled and flown repeatedly. That represents a huge philosophical shift in how spaceflight is done. During the Apollo era, lunar missions were rare national events that required enormous infrastructure, years of preparation, and rockets that were used only once. SpaceX is trying to move towards something much more routine, with frequent launches, rapid turnaround, and operational tempos that look more like an actual transportation network than a traditional government exploration program. In many ways, Starship's long-term success depends less on one spectacular launch and more on proving that spaceflight itself can eventually become routine. Version 3 Starship includes several upgrades designed specifically for that future. The vehicle now features a dedicated system for managing cryogenic propellant behavior during long coast phases in space, which is extremely important because super cold liquid oxygen and methane don't behave the same way in microgravity as they do on Earth. SpaceX has also added 4 docking drogues along the leeward side of the ship to support docking operations with other starships. Alongside those are new propellant feed connections that will eventually allow fuel transfer directly from ship to ship while in orbit. Flight 12 is expected to test parts of this future architecture, including upgraded plumbing systems and hardware connected to eventual orbital fuel transfer operations. Right now, SpaceX says the ship is capable of remaining on orbit for up to 48 hours, or about 2 full days, which is another important step toward long-duration missions and future refueling tests. The success of Starship V3 has implications far beyond SpaceX itself. NASA is currently relying on Starship as the human landing system for the Artemis program, including Artemis IV, which is intended to return astronauts to the lunar surface later this decade. But before that can happen, SpaceX must prove not only that Starship can launch and survive re-entry reliably, but also that the much more complicated orbital refueling architecture actually works in practice. That's why every major Starship milestone matters so much to the future of Artemis. Flight 12 will not complete all of those objectives, but it could provide the clearest sign yet that the overall system is finally starting to mature into a truly operational platform. And not just NASA. A lot of companies are waiting for Starship to succeed, not just SpaceX itself. Many future space businesses are basically planning their entire future around Starship becoming a cheap and reliable rocket. Right now, launching things into space is expensive, and there are not enough rockets available. Starship could change that in 2 huge ways. First, it can carry far more cargo than a Falcon 9 in a single launch. Second, it could massively lower launch prices. Falcon 9 has already made launches much cheaper, but Starship could reduce costs even more, from thousands of dollars per kilogram to only hundreds. That would make things possible that are currently too expensive, like giant satellite networks, space-based data centers, and much larger Starlink systems. It took SpaceX just 5 test flights, from Flight 1 to Flight 5, to go from their very first launch attempt to successfully catching a super heavy booster with the tower chopsticks, which honestly still feels unbelievable. Flight 1 proved that the fully stacked Starship system could actually get off the pad. And even though the vehicle was eventually lost, SpaceX learned a huge amount from the mission. Those lessons led to major upgrades to both the launch pad and the rocket itself before Flight 2. On Flight 2, SpaceX successfully achieved stage separation and even started the booster's boost-back burn toward the launch site, hitting another major milestone. Then, on Flight 3, they completed the full boost-back burn sequence for the first time. Flight 4 demonstrated controlled water landings, proving the vehicles could survive re-entry. And then Flight 5 delivered the moment everyone remembers, the successful booster catch using the tower chopsticks. Now, Flight 12 is opening a completely new phase of the Starship test campaign with the first V3 vehicle. And even if a couple of V3 ships explode along the way, it likely would not be considered a major setback. Elon Musk says SpaceX expects to build around 10 more ships and roughly 5 boosters this year alone, meaning the production pipeline is already moving at a rapid pace. The bigger concern is not losing a prototype, but damaging the launch infrastructure itself. Can you believe it? More than 90% of viewers watching still haven't subscribed yet. So if you're enjoying the videos, don't be shy, hit that subscribe button. It really helps the channel and motivates me to keep bringing you more awesome content about spaceflight. Thanks for the support.